Hello and welcome back to Engineers Olympiad, Building Concepts Brick by Brick. We have completed the first chapter of surveying, Introduction and Basic Concepts. We have completed the theory part as well as the numerical part. Now in this video lecture, we'll be doing all those questions that over the years have been asked in IES examinations, Indian Engineering Service examinations, related to the topic Introduction and Basic Concepts of Surveying. So let's start. This question was asked in IES 2000 and this is an assertion reason type question, and assertion is, in a spherical triangle, the sum of three sides is always less than the circumference of the great circle, and the reason is the sum of three angles of a spherical triangle is greater than the two right angles but less than the six right angles. So we must be knowing the properties of spherical triangle. First property is that any angle is less than 180 degree. The second property is that sum of three angles is greater than 180 but less than 540 degrees. Sum of three angles is greater than 180 degrees but less than 540 degrees. The third property of a spherical triangle is that sum of any two sides is greater than the third. Sum of any two sides is greater than the third. This is the third property of a spherical triangle. The fourth property of a spherical triangle is that smaller angle is opposite to smaller side. And the fifth property of a spherical triangle is that sum of three sides is less than the circumference of great circle. Sum of three sides is less than circumference of the great circle. So properties of a spherical triangle is that any angle is less than 180 degree, sum of three angles is greater than 180 degree but less than 540 degrees, sum of any two sides is greater than the third, smaller angle is opposite to smaller side, and sum of three sides is less than the circumference of great circle. So what is our assertion? In a spherical triangle, the sum of three sides is always less than the circumference of the great circle. So this is correct, as it is one of the property of a spherical triangle, that in a spherical triangle, sum of three sides is always less than the circumference of great circle. What is the reason? The sum of three angles of a spherical triangle is greater than two right angles but less than six right angles. So this is also correct. This is also a property of a spherical triangle, that in a spherical triangle, sum of three angles is greater than 180 degrees but always less than 540 degrees. So our assertion is correct. Our reason is also correct. So what is the answer? How can we say? See, if I'll write A, then both A, assertion and reason are true, and reason is the correct explanation of A. If I'll mark it as B, then both assertion and reason are true, but reason is not the correct explanation of assertion. If I'll have to mark it as C, then assertion is true but reason is false. And if I'll mark it as D, then I will mean that my assertion is false but my reason is true. Since both my assertion and reason are true, but reason is not the correct explanation of my assertion, so I'll write it as, this will be in the options in the question. So B, that my assertion is true, my reason is true, but my reason is not the correct explanation of my assertion, right? So this was the first question, and this was asked in IES 2000. By this we learned the various properties of a spherical triangle, that any angle is less than 180 degree, sum of three angles is greater than 180 degree but less than 540 degrees, sum of any two sides is greater than the third, smaller angle is opposite to smaller side, and sum of three sides is less than the circumference of the great circle. Moving on, and let's do another question. All right. So this question was asked in IES 2004. This question was asked in IES 2004, and the question is that we have to match list 1 with list 2. We have to match topographical survey, reconnaissance survey, cadastral survey, and archaeological survey. We have to match these surveys with the list 2, which determines their functions. I may not write it in the different order, I'll write it in the correct order, right? Topographical survey is a survey to determine natural features of a country. If you may recall the discussions as held in the theory part of the same chapter, wherein I told you that we conduct these topographical surveys to prepare topographical maps or the topo sheets of an area that has to be surveyed, and these topographical maps or these topo sheets, in addition to the plan, they also show us elevations of the terrain. That means they show us different natural features of a country. So topographical survey is a type of survey. It's one of the functional classification of the survey, and it's used to determine natural features of a country. Next one is reconnaissance survey. We use reconnaissance survey to determine possibility and rough cost of the surveying system to be adopted. To determine the possibility and rough cost of the surveying system to be adopted. So reconnaissance survey is a preliminary survey which we conduct to determine the possibility and rough cost of the surveying system to be adopted. Then comes the cadastral survey. As we have already discussed in the theory part, that we use cadastral survey to determine boundaries of fields, houses, etc. And the last one is archaeological survey. And archaeological survey is conducted to find relics or antiquity. Right, so this was a question asked in IES 2004 and in which we had to match list 1 with the list 2nd, but I wrote down the correct form and this was the question. Topographical survey we use to determine natural features of a country. Reconnaissance survey is conducted to determine the possibility and rough costs of the surveying system to be adopted. Cadastral survey is conducted to determine boundaries of fields, houses, etc. And archaeological survey to find relics or antiquity. Right, moving on, let's do the next question. These all survey types come under the classification, functional classification of surveying, right? As already discussed in the theory part of the chapter. Those videos are up on the channel Engineers Olympiad. You can watch those videos before watching this video. All right, moving on, IES 2006. This question was asked in IES 2006 and the question is, which one of the following verniers is employed in Ebne level? Which of the following verniers is employed in an Ebne level? First one, retrograde vernier. Second option was double vernier. Third option was double folded vernier. And the fourth option was extended vernier. Right? Which of the following verniers is employed in an Ebne level? Retrograde vernier, double folded vernier or extended vernier? The answer is extended vernier. We use extended verniers in an Ebne level and we know extended vernier is used when the division of main scale is small and it becomes difficult to judge the exact graduation where coincidence occurs and if the vernier of the normal length is used. Hence, in an extended vernier, the vernier graduations are made larger than those of the vernier of normal length, right? So, we use extended verniers in an Ebne level and as already told, extended vernier is used when the division of main scale is small when the division of mean scale is small and it becomes difficult to judge where the exact graduation, where the coincidence occurs between the graduations of the vernier scale and the main scale. So we use extended vernier in an Ebne level. This was the question as asked in IES 2006. Moving on next to the next question. All right, this question was asked in IES 2008. And the question is, a scale of 1 inch is equal to 50 feet. A scale of 1 inch is equal to 50 feet is mentioned on an old map. Is mentioned on an old map What is the corresponding equivalent scale? What is the corresponding equivalent scale? Let me write options first, because it's important to write options as well. Option A, 1 centimeter is equal to 5 meters. Option B, 1 centimeter is equivalent to 6 meters. Option C is 1 centimeter is equal to 10 meters, and option D is 1 centimeter is equal to 12 meters. Alright, so let's solve this question. The question is, a scale of 1 inch is equal to 50 feet is mentioned on an old map. What is the corresponding equivalent scale? What is scale as mentioned on an old map? 1 inch is equal to 50 feet, right? We know there are 12 inches in 1 feet. There are 12 inches in 1 feet, right? That means I can write it down like this. Representative fraction will be 1 by right? 1 by 600 will be my representative fraction. What does that mean? My representative fraction is 1 is to 600. That means 1 centimeter on the map represents 600 centimeters on the ground. This is my engineer scale. This is my representative fraction. Or I may write it down that 1 centimeter is equal to 6 meters on the ground. That means every centimeter on this old map represents 6 meters on the ground. That means option B is correct. 1 centimeter is equal to 6 meters, right? So we solved this question. This was asked in IES 2008. All right, moving on, let's do another question. All right, this question was asked in IES 2009. And the question is, which one of the following conditions requires geodetic survey? Which one of the following conditions require geodetic survey? We know that geodetic surveying is a primary division of surveying in which curvature of earth is taken into consideration and areas to be surveyed are larger than 250 square kilometers or so. Okay, option A, horizontal curve ranging. Option B, vertical curve ranging. Option C, survey of a country. Survey of country. And option D is reconnaissance survey. Reconnaissance survey. All right. So the question as asked in IES 2009 was, which one of the following conditions requires geodetic surveying? horizontal curve ranging, vertical curve ranging, survey of a country, or reconnaissance survey? The answer is survey of a country. Why? Because survey of a country is done by Survey of India, right? Survey of a country is done by Survey of India, which perform geodetic surveying, right? And as already told, in geodetic surveying, we take curvature of Earth's surface into consideration, and a very high degree of precision is maintained, right? So this was the question as asked in IES 2009. Let's move on to the next one. This question was asked in IES 2011. This question was asked in IES 2011, and the question is, again we have to match list 1 with list 2. This is list 1 and this is list 2. All right, so we have traverse surveying, geodetic surveying, plane table survey, and the fourth one is hydrographic survey. Traverse surveying, geodetic surveying, plane table survey, and hydrographic survey. I'll write list 2 in correct form. Traverse surveying, chain and compass. Geodetic surveying, theodolite. Plane table survey, Olympiad. And hydrographic survey, Weddell sounding machine. All right, I have written list 2 in the correct form, in the correct order rather. And in traverse surveying, it's done with the help of a compass and a chain. Geodetic surveying is done with the help of a precise instrument such as a theodolite. In plane table surveying, we use Olympiad, that is employed for sighting objects and drawing lines, and Weddell sounding machine is used to determine depth of sea in hydrographic surveying. Depth of sea in hydrographic surveying is done by using Weddell sounding machine. So this was the question as asked in IES 2011. We had to match list 1 with list 2. All right, moving on, let's do another question. We are solving all those questions which over the years have been asked in IES examination related to the chapter Introduction and Basic Concepts of Surveying. All right, this question was asked in IES 2011 also. Question is, a rectangular plot of 16 kilometers square in area is shown on a map by a similar rectangular area of 1 centimeter square. Representative fraction of the scale, to measure a distance of 40 kilometer will be options were 1 by 1600, 1 by 4 into 10 raised power 5, option C was 1 by 400, and option D was 1 by 16,000. Alright, so this question was asked in IAS 2011, and the question is: a rectangular plot of 16 kilometer square in area is shown on a map by a similar rectangular area of 1 centimeter square. Representative fraction of the scale to measure a distance of 40 kilometers will be. Right? So let's solve this. The scale is that every 1 centimeter square on a map is represented by 16 kilometer square on the ground, because it's written a rectangular plot of 16 kilometer square in area is shown on a map by a similar rectangular area of 1 centimeter square. So our scale is 1 centimeter square on the map represents 16 kilometer square on the ground. Taking square root on both sides, 1 centimeter represents 4 kilometers. That means every 1 centimeter on the map represents 4 kilometers on the ground. This is my engineer scale, or I may write it like this: 10 raised power 3 into 10 raised power 2 centimeters. That means 1 centimeter is equal to this is my engineer scale, and my representative fraction will be hence answer B is correct. Right? So I found the representative fraction of the scale, wherein every 1 centimeter on map represents 4 kilometers on the ground. Right? All right. Let's move on and do the next question. This question was asked in IAS 2011. One more question was asked in IAS 2011 regarding the same chapter, and the question is: working from whole to part, is followed as the fundamental principle of surveying so as to A. distribute errors B. Improve ease of working. C. Prevent accumulation of errors. Prevent accumulation of errors. And D. Compensate errors in a way and E, fifth statement was refer to a common datum, say MSL. Mean C level. So this question was asked in IAS 2011, and the question is, working from whole to part is followed as the fundamental principle of surveying so as to distribute errors, improve ease of working, prevent accumulation of errors, compensate errors in a way, and refer to a common datum, say mean C level. We have to see which of the statements is correct, right? Option A. Two and 5, right? We have to see which option is correct. As we know that working from whole to part is the fundamental principle of surveying, but so as to what? So as to prevent accumulation of errors and compensate errors in a way. Right? This is the fundamental principle of surveying. What? Working from whole to part to what? To prevent accumulation of errors and to compensate errors in a way, not to distribute the errors, not to improve ease of working, and not to refer to a common datum, say MSL. So my C statement, my third statement, please do not confuse yourself. This is 1, this is 2, this is 3, 4 and 5. So my statement third and fourth is correct. So the correct option will be 3 and 4. Working from whole to part is my fundamental principle of surveying to prevent accumulation of errors and to compensate errors in a way, not to refer to a common datum, say MSL, and not to improve ease of working and not to distribute errors. Right? So this was the question as asked in IAS 2011. Okay? Let's move on. This question was asked in IAS 2013. And the question is, which one of the following statements is correct? Statement number 1A. In retrograde vernier, n-1 divisions on the primary scale n minus 1 divisions on the primary scale are divided into n divisions on the vernier scale. Are divided into n divisions on the main scale, vernier scale, sorry. B, a double vernier consists of two simple verniers placed end to end with 0 at the center. In an extended vernier, in an extended vernier, 2n plus 1 primary divisions are divided into n divisions on the vernier. And the last option was in a direct vernier, n plus 1 primary divisions n plus 1 primary divisions are divided into n equal divisions on the vernier scale. Right? So this was the question as asked in IAS 2013, and we have to say which of the statement is correct. Okay, one by one. Statement number 1. In retrograde vernier, n minus 1 divisions on the primary scale are divided into n divisions on the vernier scale. Wrong. In a retrograde vernier, n plus 1 divisions on the primary scale are divided into n divisions on the vernier scale, because in retrograde vernier, n divisions on the vernier scale correspond to n plus 1 divisions on the main scale. So this statement is wrong. Let's take this statement. In an extended vernier, 2n plus 1 primary divisions are divided into n divisions on the vernier. Again wrong. Why? Because in an extended vernier, n divisions on the vernier scale correspond to n minus 1 divisions on the main scale. So this is wrong. In an extended vernier, 2n minus 1 primary divisions are divided into n divisions on the vernier scale, not 2n plus 1. Let's take this one. In a direct vernier, n plus 1 primary divisions are divided into n equal divisions on the vernier scale. Again, this is also wrong. Why? Because in direct vernier, n divisions of the vernier scale correspond to n minus 1 divisions on the main scale. So the statement in a direct vernier, n plus 1 primary divisions are divided into n equal divisions is wrong. Why? Because in a direct vernier, n minus 1 primary divisions are divided into n equal divisions on the vernier scale. So the correct statement is the last one remaining, and that is a double vernier consists of two simple verniers placed end to end with 0 at the center. Yes, this is true. A double vernier indeed consists of two simple verniers placed end to end with 0 at the center. All right, this was question asked in IS 2013. Moving on. Let's do another one. This question was asked in IS 2014. And the question is, a plane which is perpendicular to the plumb line through a point and is tangential to the level line to the level surface at that point is called option A was tangential plane. Option B, vertical plane. Tangential plane, vertical plane, level plane, or the horizontal plane. All right, so this was a question as asked in IES 2014, and the question is, a plane which is perpendicular to the plumb line through a point and is tangential to the level surface at that point is called as tangential plane, vertical plane, level plane, or the horizontal plane. The answer is horizontal plane, right? Because the horizontal plane is normal to the direction of gravity, and direction of gravity is indicated by a freely suspended plumb bob at that point, right? So the answer is horizontal plane. All right, moving on. Okay, this question was asked in IES 2015. And the question is, consider the following statements. Consider the following statements. The general principles of surveying are: the general principles of surveying are: 1. To work from part to whole. 2. To locate a new station. To locate a new station by measurements. To locate a new station by measurements from at least two fixed reference points. Already established or identifiable. Already established or identifiable. Okay, and we had to report which of the statement is correct. One only, B, two only, C, both 1 and 2, and option D, neither 1 nor 2. Alright, so this was the question as asked in IES 2015, and the question is, consider the following statements. The general principles of surveying are to work from part to whole, to locate a new station by measurements from at least two fixed reference points already established or identifiable. So which of the statement is correct? We know that to work from part to whole is not the principle of surveying, because the general principle of surveying to minimize errors is that we have to work from whole to part, not from part to whole. So this statement is wrong. The second statement, to locate a new station by measurements from at least two fixed reference points already established or identifiable, is correct, because this is the general principle of surveying, that we have to locate a new station by measurements from at least two fixed reference points already established or identifiable. So only second statement is true, right? This is the fundamental principle of surveying, to prevent accumulation of errors, that we have to always work from whole to part. All right, so only second statement is correct, and option B is the correct answer, right? So this was the question as asked in IES 2015. All right, let's move on. This was the question asked in IES 2016. And the question is, Survey of India was publishing topo sheets. Survey of India was publishing topo sheets using a scale of option A 1:1000, option B 1:5000, option C 1:10,000, and option D was 1:50,000. Alright, so this was a question as asked in IES 2016, and the question is Survey of India was publishing topo sheets using a scale of 1:1,000, 1:5,000, 1:10,000, or 1:50,000. Alright, so Survey of India used to publish, so if India was publishing topo sheets using a scale of 1:25,000, 1:50,000, and 1:25,000, 1:50,000, and 1:250,000. But this practice was stopped after the adoption of National Mapping Policy of 2005. After the adoption of National Mapping Policy of 2005, this practice was abandoned, and Survey of India no more used to publish any topo sheets. But before that, before the adoption of National Mapping Policy of 2005, Survey of India was publishing topo sheets using these scales. Since we don't have this option, we don't have this option, so the correct answer is this, and option D is our correct answer. Alright, so Survey of India was publishing topo sheets before the adoption of National Mapping Policy of 2005 using a scale of 1:50,000. So option D is the correct answer, right?